Pleasure to be here. It's great. On the MSU chemistry department page, when I pull up the faculty, there are 5 or 6 people in a row that have been part of my life over the years, and so it's a pleasure to come back and visit. I spent 10 years in industry working at Polaroid. I spent 10, 11 years as a professor teaching at UMass. Spent the last 10 years as an entrepreneur running a startup company. We haven't really, in this place of chemicals policy and sustainability, we've not really been asking the right questions. Instead of asking, which the biggest, most fundamental question that we should be asking is, why would a chemist make a hazardous material in the first place? So how did that happen? So instead of asking how do we make molecules, maybe we got to be asking ourselves, how do we make chemists? I was very introspective about the chemical sciences. We do amazing things in chemistry, right? The pharmaceuticals, the ag agents, the electronics, all the different things that we make are so cool. But the way we manufacture everything's at high temperature, everything's at high pressure, everything uses harsh reagents, and yet, as a medicinal chemist looking at physiological processes, everything we do in natural systems, in the birds and the bees and the bunnies and the bugs, all of those things happen, the molecular diversity and complexity outperforms humans, hands down, but everything happens at room temperature. Everything happens at ambient pressure. Everything happens in water. My epiphany was that in nature, there is never a reactive collision. Always in nature, in a semi-viscous state, the molecules use those very same molecular orbitals and atomic orbitals that govern reactivity to govern orientation. And they actually snuggle up to each other first. Then they react. So I started looking. In the United States, every year, we graduate 15,000 undergraduates in chemistry, 3,000 masters, and 3,000 doctoral degrees. In 2004, more women started becoming chemists than men. What could be more important to the field of chemistry than an understanding of reproductive hazards, of carcinogenicity, of toxicity, and yet, not one university in the world requires a chemist to show any expertise in understanding what makes a molecule toxic. Because my definition of green chemistry is, yes, the technology must have some benefit to human health and the environment. But if it's sitting on the shelf with people celebrating it just by talking about it, and it's not successful in the marketplace, it's actually not solving any problem. So for it to solve a problem, it's actually got to work better than any other technology. It's got to cost better than any other technology. So the way the Warner Babcock Institute works is most of our business is contract invention, not contract research, contract invention, where the multinationals or the small companies pay us to invent. We invent, file the patents, and then make a deal on how we'll share in the profits. The sponsor of this event and working with the great people in the pavement industry around here, Collaborative Aggregates, wait for it, okay, and is our material science company, and then Collaborative Medicinal Development is our pharmaceutical company that has little spin-outs underneath that. We started a company called Collaborative Aggregates. The product, I wanted them to call it entropy mix. And they said, couldn't never call it entropy mix. I said, how about delta S? They go, we like that. Here I am. I'm wearing a hard hat and boots, holding a shovel, digging in a pile of asphalt. And my cell phone goes off, and it's clinicians in Finland talking to me about the results of the Alzheimer's drug. Now, wait a minute. Asphalt, neuroscience, that doesn't quite go. But wait a minute. My mechanism for Alzheimer's is there's a protein in the brain that wraps around an inorganic particle, and it aggregates. And so the molecule that we invented slips into the interface and controls the way it aggregates. What is asphalt? Organic polymer wrapped around a particle. What is delta S? A small molecule that slips into the interface. It's the exact same thing. We in science, we love to define ourselves. I'm a medicinal chemist, I'm a cosmetic scientist, I'm in construction. A molecule doesn't know what industry it's in. If you just look at molecular structure and molecular behavior, you kind of can play all over the place. And so while we're solving the asphalt problem, we're learning about Alzheimer's. While we're working on Alzheimer's, we're solving problems in asphalt. At a molecular level, they all just kind of go together. But the point is, I would argue the Warner Babcock Institute is no more smart, no more creative than any other group of people. Okay, we're not successful because of some magic. Okay, what I feel it is that we're successful not in spite of green chemistry, but because of it. What about saying, let's focus on human health and the environment as a design feature? It doesn't slow you down. I don't feel slowed down. What I've just described to you is just in the last 4 years with under $6 million of investment. I don't feel that this slows me down, but I don't think that we're anything special. I think that it's just when you free your mind to see that these constraints in green chemistry project you forward in creativity, it's where it's at. Michigan State University signed the commitment, and so I am so proud to be here at Michigan State where you guys are leaders of the field of green chemistry. You guys are the epicenter of where things are happening, and I thank you so very much for doing that, and I thank you for listening to me babble.